program we look at a system of equations. We look at two equations with two unknowns, and generally you can solve those as well. And in fact, in higher algebra you might come across three equations with three unknowns. Let's have a look at an example there. If I've got an equation such as x plus y equals 10, then you'll find that there are many possible solutions. I've got some written here, x equals 5, y equals 5, because together that adds up to 10. See, that's sometimes written as what's called an ordered pair, 5, 5. There are other solutions, and I've got another one there, 0, 10. Also, those two numbers add up to 10. And again, that's written as 0, 10. So we don't see a unique solution for x and y. However, if I now going to introduce another equation like this one, x minus y equals 2, there generally will be a unique solution. And in fact, in this case, the unique solution is x equals 6 and y equals 4. And you can check that in. 6 plus 4 is 10, and of course 6 minus 4 is equal to 2. And notice again this way the solution is written as an ordered pair. What we say is that we've solved a pair of simultaneous equations. Now there are various ways of solving simultaneous equations. Some are easy, some are more difficult. In fact, many calculators nowadays can solve these equations for you. You of course have to know what to put into the calculator before you get a result. But yeah, that could be regarded as one method. But generally there are about 4 methods, and I've got those listed on the screen. The first method is called substitution. The second one, elimination. The third one, using determinants. That's to do with matrices. And then there are graphs as well. Now, the substitution one is probably the most difficult algebraically. The elimination one is the easiest, but you have to rewrite the equations in a particular format. Determinants, for those people who are good at matrices, it's a very easy method. It's called Cramer's rule. We haven't got time for that in this subject. And there's a graphical method that's not always exact, and that we will cover in the next program. And then, as I mentioned, of course, you can use a calculator as well. I'm going to give you now an example of these two methods that we concentrate on, the substitution and the elimination method. So here we go. There we've got that system of equations, as it is sometimes called, x plus y equals 8, x minus y equals 2, and that is what's sometimes used to keep those two equations together. The equations are numbered quite frequently as well. And with the substitution method, what you do is you express one variable in terms of the other. Now, I've taken equation 1 and I've rewritten that as y equals 8, and I've transposed the x to the other side. 8 take x. Then we substitute that in the second equation. So rather than writing y now, I write 8 minus x. And then I end up with one equation in one unknown, which can be solved in the usual fashion, where we combine the two x's there and we bring the negative x to the other side. 2x equals 10, from which we get x equals 5, of course. And then I can use the third equation there to get the value for y, because I know that y is 8 with 5 subtracted. In other words, y is equal to 3. Let's now do the same problem using the elimination method. So here we go. We've again numbered these equations 1 and 2. And what you do in the elimination method, you put the two equations underneath each other and you try to eliminate one of the variables. In this case, you would add the two equations together and then you add in columns. So you get an x and an x there, 2x, and you'll find that the y and the negative y will cancel out, and the 8 and the 2 will become 10. And of course, from that we get straight away x equals 5. Once you now know that x equals 5, we write that down. Then again, you write down the two equations, and in this case, we can eliminate the x by subtraction. And if you subtract, and that's the difficulty there, you're going to get to 2y, because what you do is you get y subtract negative y. So that becomes y plus positive y, which is 2y. And that's where, of course, the mistakes are made. And that equals 6, and from that we get y equals 3. So the solution again is x equals 5, y equals 3. Now both methods are fine, What I suggest is that you use a sort of a combination of the two methods. What I always do is I do the substitution method last. I first start with the elimination method. I'll get one of the variables and then I use substitution to get the full result. And that's what I've got here on the screen. So the suggested procedure is to write the equations in the form ax plus by equals c. Use the elimination method to obtain the value of one variable, and then you use the substitution to obtain the value of the other. Straight into that same problem as we had before. See, exactly the same equations. And first eliminate. And we've got 2x equals 10, from which we get x equals 5. And then I use either 1 or 2 by substitution to get the second value. Use x equals 5 in the first equation, and from that I get 5 plus y equals 8, from which we get, of course, y equals 3, written 5, 3.